All right, so on this one here, when we start with domain, how do we find domain again?
You plug the denominator to 0.
Yeah, so that means x squared plus 4 cannot equal 0, right? But when I go to solve this, that means x squared cannot equal negative 4. Why couldn't I factor that one? Yeah, because it's not a difference of squares, okay? Which I think is what was being asked about. You can't factor it because it's not a difference of squares, so there's no way to factor it. Because when you go to do this, you take the square root. You actually get x will equal plus or minus 2i, right? Because of the square root of the negative 4. And when we're talking domain, we're talking about our x's and our x number line. Do we have any i's on there? No. So this just means there's no restriction, which means what is my domain? Yeah, well, there is a domain. There's just, there's no restriction. Therefore, it's all of it. So it's just negative infinity to infinity. So because I couldn't factor that, and everything's factored as far as it can be, do I have any holes?
No.
No. What about vertical asymptotes?
Nope.
There's none of them either because there's nothing x can't be to be a hole or vertical asymptote, right? There were no restrictions. That means automatically there's no holes and no vertical asymptotes. What about a horizontal asymptote?
You can't plug.
Where's the highest degree?
At bottom.
On the bottom, and what is it if it's on bottom?
It's y equals 0.
Y equals 0.
But you can't factor it. Oh, yeah.
You don't have to factor it, okay? You don't have to factor it for the horizontal asymptote. All right, X-Intercepts. How do we find those? Numerator equals 0, so x minus 2 equals 0, which means it's at x equals 2, so at 2, 0. And how do you find your y-intercept? All right, 0 for x.
You do it for the top or the bottom?
For both. So you got 0 over 2 over 0 squared plus 4. So negative 2 over 4, which is... So 0, negative 1/2. All right, so go ahead and graph those real quick here. I'm going to pause the video. All right, so we've got it set up here. But the question is why do I have a horizontal asymptote and an x-intercept? Because remember, horizontal asymptote deals with end behavior. We will never, ever, 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 ever cross a horizontal asymptote at the ends. But you can cross it somewhere here in the middle, okay? It's okay to cross in the middle, just not at the ends. Doesn't happen real often, but it can happen. All right, so let's do our number line. And what do we put on our number lines? X-intercept and vertical asymptote. And I have an x-intercept at 2. So I need, this is what, step 8, because I'm bad about labeling my steps. All right, so I need a number between negative infinity and 2. 0. We already worked it. It was our y-intercept, which was negative 1/2, right? And so I've got that right there. And so what's going to happen there, guys, is because remember you have to hug the horizontal asymptote or any asymptote. So I know as I go to the left, I'm going to have to go towards that horizontal asymptote, but I've got to go through that point. So watch. As I come out of the 2 to the left, I'm going to have to cross through that y-intercept, that point there, but then I'm going to come back and kind of hug that horizontal asymptote. All right? So it kind of dips down and then comes back towards it. So let's pick a number in our interval from 2 to infinity.
Don't do 3.
Don't do 3?
It gets to 113, and that's hard to grasp.
Okay, so
5.
5.
863.
I don't think there's going to be any pretty number for it, though. So we got 5 minus 2 over 5 squared plus 4. So that's 3 over 25 plus 4, which is 29.
Perfect.
Okay? So, but the main thing, guys, is where, even if we use the 3 and we got 1 over 13, it's still just right above the x-axis, right? So when I go to graph this, I would do 5 and 1 over 29. So somewhere just above the x-axis. If you did the 3, you got 1 over 13. Again, you're just above the x-axis there somewhere, okay? So it's the same idea. We're going to come up, we're going to hit that point, and then we're going to come back to hug that horizontal asymptote. Okay, so it just goes up a little, and then it comes back down.
Cool.
And then the only thing we have left now is they didn't ask me about the range, but they asked me about the end behavior. So tell me on this, look at it. As my x is going towards negative infinity, what is my y value going towards?
Infinity.
No.
No,
Look right here, guys. As I'm going this way, what does y seem to be approaching?
0.
0. And as my x then goes to the right towards positive infinity, what does my y value appear to be approaching down there on the right? Also 0. Because remember, that's the definition of the horizontal asymptote, right? As x is going towards positive and negative infinity, the y value should be going towards the same number if there's a horizontal asymptote there. All right, so there's our graph and our information.